Okay, so our first conic section we're going to look at would be parabolas. And again, we know a lot about parabolas. We've graphed a lot of them of the form, some form y equals x squared. Just remember, with parabolas, only one of the two variables is going to be squared. The rest of the conics are going to square both x and y. So that's a really easy way that we can recognize that we have a parabola. If we see it with an x squared, it's going to either open up or open down. And if we see it with a y squared and just an x to the first power, it's going to open to the right or it's going to open to the left. So we'll look at how we can tell which is which here. But for these, we kind of look at some different equations, different looks for the up and down versus the side-to-side one. So in your little table here, the first equation, it's probably easiest to think about x squared equals 4py. Or right in that same box, you also might put x minus h squared 4p y minus k. And this is the old h and k that were our horizontal and our vertical shifts. Right? So what that would so we're going to look at, this is just sort of the generic one, which has a vertex at the origin. We'll write that up here in a second. And this one is where the vertex is shifted and is now an hk. But really, once you find the new vertex, as we graph these, you're going to see everything just works the same way. Okay, so there's going to be a lot of equations. You can kind of get a feel for it, and you don't need to just memorize equations. If you get a feel for it, they're not so bad. So if it looks like this, it's either going to open up or it's going to open down. And the difference being it opens up if p is greater than 0. And it opens down if p is less than 0. And we'll talk a little bit more about what p is. And this is a different form of a parabola. I know you're used to probably seeing y equals, right? Where when we're doing this form, it's going to be a little bit different than that. The vertex would be for the standard one, would just be at 0, 0. For the translated one, would just be at hk. That's where our vertex is going to be. And then we have what's called the directrix, which we should probably talk about what that is, but it would be the line y equals negative p or y minus k equals negative p. Again, we're going to talk about what that is in just a second. I can kind of show you that. And then the other sets, the other row here, would be y squared equals 4px. Or y minus k squared equals 4p x minus h. So again, we see the x and the y kind of change places there. Right now it's y squared equals. This is either going to open to the right if p is greater than 0, or to the left if p is less than 0. The vertex here is 0, 0 again. Or if it's shifted, it would be at hk. And then the directrix this time is going to be vertical, so it's either going to be x equals negative p or x minus h equals negative p. Now as we look at more of this, I think it'll become clear what all these pieces are. But these are just sort of the facts we want to refer back to. Now, to understand what these mean in terms of what the directrix is, and we're going to talk about another point called the focus, we need to define what a parabola is. Okay. And then again, p is the distance from the vertex to what's called the focal point. So any point on a parabola, any point on a parabola is equidistant, same distance, from a point called the focus, and a line called the directrix. Which is perpendicular to the axis of symmetry. Now, what that means is, for every parabola, whether it opens up, down, left, right, tilted, like you can have them tilted. We won't really do that. You're going to have some line called the directrix. Okay, and then you're going to have some point on your parabola called the vertex. Now the parabola is always going to open away from the directrix. It looks something like that. And then out here will be a point called the focus. So this is the focus. But as you notice, any point on the parabola, if we take any point here, and we measure this distance, and we measure this distance, they're going to be the same. That's what a parabola is defined as. It's the set of points equidistant to a point in a line. But the point's called the focus. The directrix is the line. The parabola always opens around the focus, right, and away from the directrix. So if it opens up, the focus will be above the vertex. If it opens down, the focus will be below the vertex. Right or left, same thing. The reasons we care about a parabola, just a couple quick ones here, is that if you have a bunch of parallel wave or rays or whatever, anything's coming into a parabola and they bounce off. So say we have a bunch of sound waves coming in here or electromagnetic radiation, they're all going to bounce and they're all going to go right through the focal point or the focus. So a couple applications you've seen is a parabolic microphone, because its cross section is a parabola, right? Those are the ones on the side of like a football game, like big plastic ones, right? And it bounces them back. It bounces the sound waves off the plastic and it bounces them all through the focus, and that's where they put the microphone. So you can hear things from really far away. A satellite dish is the same idea, right? It's a parabolic cross section. The focus is where the receiver sits. Same idea though is if you have something emitting from the focus, it'll bounce back, and if it bounces off, they'll all come out at parallel wavelengths. That's how a car's headlight works, or a lot of flashlights work, is that you have a bulb here. This is a parabolic mirror, right? And it makes the rays go out parallel. That's why you can aim your headlights. That's why you don't just screw a light bulb in the hood of your car and try to drive. It wouldn't work. But that's one other application of that. Or like if you have a flashlight, an adjustable flashlight, right? You know, sometimes you get a really tight, bright beam, correct? And then sometimes it's really wide. And what do you call it when it's really tight and bright? A lot of times you'll hear it called in focus, because the bulb is at the focus, right? As you get away from the focus, you lose that parallel idea there. So that's why we might care, but it tends to be seen how much we care, I guess. So, but just kind of interesting to note that there are applications of that. So we want to look at the 4 different cases here. I went ahead and included these shifts, but it's easier to try to understand these just by looking at these centered with the vertex at the origin, right? And then if we need to translate them, we do. You just translate the vertex and everything else comes off the vertex. What's really going to be important here is this number P. P is going to tell us how far we go from the vertex to the focus and from the vertex to the directrix. And once you know that, you kind of have it done. So let's see, there's another piece that I like to use a lot. It's called the focal diameter, and I'll show you what that is. And that's just the absolute value of 4p. And all that is at the focus, level with the focus, that's how wide the parabola is. So it gives you a couple really quick points that you can graph without much trouble. So let's go ahead and look at our cases here. So in all of these cases, the vertex is going to be at 0, 0. And the focus and the directrix lie the absolute value of p units from the vertex. Okay, so we find the vertex, and we're going to go from there. So let's kind of run through this. I think it'll make more sense as we look at it. here for example 1, we have x squared equals 4py with p greater than 0. And again, what we're going to see with our equations when you graph them is you're not going to have p listed there. There's just going to be a number times y. We just have to be aware that that number is 4 times p. And just use a little equation to figure out what p would actually be. So in this case, if you have an x squared, that tells us up or down. Right? If p is greater than 0, it's going to open up. So in this case, our vertex would be at the origin. P units above that would be our focal point. So this would be the point 0, p. Does that make sense why it would be p units up? And then if we go p units down, we'll get the directrix. And it is the equation y equals negative p. Does that make sense there? So again, we started at the vertex. We went up p units to find the focal point, or the focus. We went down p units to find the directrix. Right? We know if it's opening up, the directrix will have to be horizontal. And then when we graph it, in terms of this whole focal diameter thing, it just means that the width from here to here is 4p, which is kind of nice. When we know that number, it's nice to draw that. So actually, this point would be like, I guess 2p comma p, and this would be negative 2p comma p. But it's just easier to just plot them. So, hey, it's 6, so we'll go 3 this way and 3 that way. Here we go. Now the next case we have is again x squared equals 4py, but this time p is less than 0. So if p is less than 0, that means that we're going to open down. So in that case, vertex is still at the origin. The focal point will be at 0p, right, because p was negative. So 0p would still be negative. You don't need to, it's still just p there. And then here we get the directrix, and it would be the equation y equals negative p. And this would open down. Okay, so our third case would be if you have y squared equals 4px with p greater than 0. I guess these were cases. I called them examples, but those were just the cases 1 and case 2. But in this case, we see that it has y squared. And notice in all these cases, the x squared is by itself. The y squared is by itself. That's the form we're going to write it in. A little different than what you've seen in the past. But for this one, since it's y squared, we know it's either going to open to the right or to the left. Since p is positive, it's going to open to the right. So in this case, again, our vertex is still at the origin. Our focal point is going to be at p0. And then the directrix is over here, and that is going to be x equals negative p. Well, that's a terrible problem. Try better. And that's going to look like that. So you're going to open to the right. And then our fourth case is y squared equals 4px. P is less than 0. So again, our vertex would be at the origin, right? And then we know that because there's no h's or k's. It's not y plus 2 squared. It's just y squared. So we know that it's going to be at 0. And then x. So then over here we would get the focal point. Again, it would be at p0. The directrix would be over here at x equals negative p. And like always, it opens around the focus. Opens towards the focus. Okay, so let's go ahead and actually graph one here. This is our first example, x equals -1/6 y squared. Now if you look back at your paper where we wrote those formulas, we want y squared by itself. Okay, so to do that, what I'm going to do is multiply both sides by -6. I like to multiply by the reciprocal. So we get -6x equals y squared, or we could say y squared equals -6x. So looking at this, what we know right away is there's no h or k here. There's no shifts going on, correct? So because of that, so since h of k is equal to 0, 0, that means our vertex is at 0, 0. Right? So kind of our standard nice example, right? Vertex is at 0, 0. Now, the next thing we'll have to find is, well, we can look at it. So here's what we're graphing. It has a y squared, right? So that tells me it's not going to be up or down. It's either going to be left or right. And I see here that this is -6. So we're going to say 4p equals -6. Right? 4p equals -6. Divide both sides by 4. We get p is equal to -3/2 or -1.5, however you want to write that. Well, that we know now it's going to be a side-to-side one, correct? So what this tells us is we're going to go p units to the side to find our focus. So our focus is going to be over here at this point, and it's going to be the point -3/2, 0, and that's going to be our focus. Okay, and then the other side is where our directrix is going to be at. So if we see the focus is 1.5 units to the left, we're going to go 1.5 units to the right of the vertex, and that's going to be our directrix. So that's going to be right here. And that would be the equation x equals, because it only hits the x-axis, 3/2. Okay, and then next up here, you could just draw it kind of randomly, but here's where that focal diameter really comes in handy. We saw that our 4p was -6, correct? Well, the focal diameter is just going to be 6. You're just going to drop the negative off it. What that means is at the focus, the parabola is 6 units wide. So that means from the focus, I'm going to go up 3 units, and I'm going to go down 3 units, and those points are going to be on the parabola. And that is going to look like that. So the focal diameter is just the distance between these 2 points. So it's just a really nice way to get a pretty accurate graph by using that versus just sort of freehanding it. What else did it ask us? Anything else? So we have the focus, we have the directrix, right? We have the vertex, we have h and k. Any questions with this? Yeah.
I'm confused on the stuff. Where did you get the 4p?
That's just all of our formulas that we had. The question was where did the 4p come from? The general formula for a parabola was just, right, it was y squared equals 4px. So whatever, that's a great question though, whatever that constant is multiplied by x, or if it's open and up and down multiplied by y, whatever that is, that's going to be your 4p value. And then you're going to find p is going to show you how far to go to find your focus and to find your directrix. Okay. So here's our next example. It's x minus 2 squared equals 4 times y plus 3. Now with this one, the first thing we have to do is get the correct h and k. That's where everything's going to start from. We're still going to move p units whichever direction to find the focus and directrix. But remember, with our old transformation stuff, if it says x minus 2, that means h would actually be positive 2. I always like to think it's whatever makes you get zeros in the equation. Right? Because if you put a positive 2 in there, it's going to make that be 0 squared. That's the thing that we're looking at there. Then here is y plus 3, so then k would be negative 3. Once you know h and k, remember h always comes from the x's by the x, k always comes by the y. We know that our vertex is 2, negative 3. So knowing that, and we know that 4 times p is 4, take a second and try to graph the rest of this. Okay, so here for example 2, we just said that the h and k were 2 and negative 3, and then the vertex would be at 2, negative 3. So I'm going to go ahead and plot that, 2, negative 3, label that with a v. Okay, now, for this equation, this 4 right here is the number 4p, correct? That's what that means. That's the constant multiplied by the first power 1 or whatever. So 4p equals 4, p equals 1. So that means to find the focus, we're going to move 1 unit from the vertex. The question is, which direction? Well, it's an x squared, so is that going to be an up, down, or side to side?
Up, down.
Up, down. So I'm going to move up 1 unit. So that would put the focus at 2, negative 2. What about the directrix? Well, that would be y equals negative 4. Very good. And I know it's y equals because it only hits the y-axis. A student told me that a couple years ago. I like that. And then the focal diameter, again, you don't always see it talked about, but it would be 4, right? This is just the absolute value of 4, which is 4. And that means at the focus, you would go 2 units to the right and 2 units to the left to find 2 more points on the parabola. So it looks like so. That would be our graph there. Questions on that one? The third example here is write an equation for the parabola, which we can do. The first thing though to figure out is which model do we want. Does this one open up or down? It does, right? For example 3, so we know it's going to be x squared. Well, it's going to be x minus h squared is 4p y minus k. Now, the vertex, though, is right at 0, 0. So since the vertex is at 0, 0, that tells us what h and k are. So h and k are both going to be zeros. Okay. Now, the only thing left to find is what, so this would be x squared is 4p y. As soon as we find what p is, we'll be in good shape now. That would be the distance between the vertex and the focus would be p. Well, we know the focus is up here, but it doesn't show on the graph. It's not given to us. But here we do see the distance between the vertex and the directrix. Right? That's a distance of 2 down. So the focus must be 2 up. So that means p would be 2. So we get x squared equals 8y. And if you check, if you look, actually you're going to see a point up here at 4, 2, and at negative 4, 2. Those would be the endpoints of the focal diameter. And I know we're short on time. Let me get this last one here. Write the standard form equation of the parabola with vertex at negative 2, 1 and focus at negative 1, 5, or negative 5, 1. What I would do here is if we just plot these, we'll pretty much be done. So if this is the vertex, this is our h and k, correct? That's the vertex. And then from here, if we plot them, let's see, 1, 2, 3, 4, 5, negative 5, 1, and then negative 2, 1. This is the vertex. This is the focus. So the vertex is a point on the parabola, correct? And it opens around the focus. So that means this has to look something like this. So it means it opens to the left, correct? So that means our equation is going to be y squared equals 4p, y minus k squared equals 4p x minus h. So the only thing we know h and k, we have to find p, which is just the distance between the focus and directrix, correct? So that distance would be -3. Okay. So then here we get y minus 1 squared, and then -12 x plus 2. So that would be our equation. Now, if you really want to check it, you could try to get it to say y equals and graph it. It would show you half of it. You could match some points up, something to try. But really, hopefully that makes sense there.